Okay, this is the introductory video into inverse trig, and I'm going to start with the sine function. So I'm going to start with a couple things that we already know about inverse functions. One, inverse functions undo operations that are done by the initial function. When you look at the graph, an inverse function is the original function reflected over the line y equals x. To find an inverse function, simply switch the x and y values. So we want to make sure that our inverse function is exactly that. It's a function, right? So in order for something to be a function, going way back here, you know that it needs to pass the vertical line test. So what I have here is the sine function. And if you were to draw vertical lines, you would only hit this graph one time with each vertical line, and therefore this is a function. So we talked about a long time ago an inverse. In order for a function to have an inverse that is also a function, that original function also has to pass the horizontal line test. So if I were to draw a horizontal line, I would clearly hit this graph more than once. Okay, so by doing that, I'm not passing the horizontal line test, which means that the inverse of this would not pass the vertical line test and therefore would not be a function. So we have to restrict the domain of this y equals sine x so that we can then find the inverse and that inverse be a function, right? So what I want to do is I want to take like just a snapshot of this where I get all unique y values so that when I do the inverse, those will be unique x values and therefore will be a function. Okay, so for the sine function, the domain of the sine function is all real numbers, right? Like this continues on forever along the x-axis. I can plug in any x I want to into the sine function and get a value. The range are the y values that we have, which would be -1 to 1, right? So if you look at this graph, it's always strictly between -1 and 1 as a y value. Okay, so that's my range, -1 to 1. Now, again, it's not as simple as to do the inverse sine function to flip these. Okay, for some functions it is. For 1-to-1 functions, all I got to do is flip this, and that becomes my inverse sine function, or my inverse function. But what I have to do here is I have to look at a part of this graph where we have all unique y values. Okay, all unique y values, and that part is going to be from -π/2 to π/2. If I look at that range from -π/2 to π/2, that part of the graph has all unique y values, meaning every single y value over that span is different. Okay. Now, as soon as I get to π/2, I start to repeat y values. Right. If I go back down here, I'm repeating some of these same y values, and as soon as I get past -π/2, I'm repeating some y values over here. So I'm going to restrict this graph to this -π/2 to π/2. And essentially what I'm doing is thinking about my domain being restricted there, which means my range for my inverse sine function is going to be -π/2 to π/2. Okay, and I'm going to show you that really quickly in Desmos and what that looks like. So here's my sine function. If we graph sine or inverse sine, that's just this little segment right here. That's all that graph will be. Okay, it doesn't continue on. Now, if I didn't restrict it, it would continue on looking like the sine function, but over the y-axis. But again, that wouldn't be a function because it wouldn't pass the vertical line test, right? So by restricting my sine function to this -π/2 to π/2, which I'll go ahead and do, -π/2 to π/2, what I see here is that those two pieces are going to be reflective about the line y equals x, which every inverse is, okay? And therefore, by doing that, now I'll have a restricted part that does have an inverse, okay? And then the range will become the domain here. So this is just going to be from -1 to 1. And as you see that on your inverse sine function, let me take everything else away. the inverse sine function, the domain is from -1 to 1, right? The graph is strictly between -1 and 1. And then my range, I'm going to change this real quick so you can see this. The range simply goes from -π/2 to π/2. Okay, and that is my inverse sine function. Okay, now what does that mean? That means that when you plug something into inverse sine, the thing that you plug in has to be between -1 and 1. Right? And that should make sense because when we do the sine function, we get something between -1 and 1. So I have to plug in something that is going to give me a sine value there. So plug in something between -1 and 1. And the range that I get that from is going to be from -π/2 to π/2. Now, thinking about the unit circle here, the top quadrant, quadrant 1, those are angles ranging from 0 to π/2. Now we're going to go from -π/2 to π/2. So that means we're going to include this quadrant 4, but instead of thinking that as 3π/2 at the bottom, I want to think of that as -π/2. Right? So that is where we're going to look for our sine value. Okay, so we're going to think about that, and then we're going to look at our trig chart, right? So if we're evaluating inverse sine, we're saying, all right, the inverse sine of 1/2. So what angle has a sine of 1/2? And that angle has to be somewhere over here, right? So there are two places that have a sine value of 1/2, and I'll pull that up right here. So where is sine 1/2? It's 1/2 at π/6, but it's also 1/2 at 5π/6, right? So I have to know which one to choose. So which one of those angles is between -π/2 and π/2? And the answer is the π/6. So when you're looking at sine, again, you're looking quadrant 1, and you're looking quadrant 4, but you're saying negative the angles that are in quadrant 1. Okay, it's as easy as that. So which angle has a sine of 1/2? That was π/6. That's my answer. So which angle has a sine of -1/2? Well, if I looked at my trig chart, I would get two angles down here, one in quadrant 3 and one in quadrant 4, and those would be 7π/6 and 11π/6. But I don't want to call it 11π/6, right? Because it has to come from -π/2 to π/2. So all I have to do is, because the inverse sine of 1/2 is π/6, the inverse sine of -1/2 is -π/6. Okay, and that's between -π/2 and π/2. All right, arc sine, I haven't mentioned this yet, but arc sine is just another way of saying inverse sine. So you're going to see both of those, and I've got those listed right here. They mean the same thing. Okay, so what angle has a sine of 3/2? Okay, I'm going to skip that one for just a second. I'm going to come back to it. D, we've got arc sine of √3/2. Okay, √3/2 is a unit circle angle. Which angle from -π/2 to π/2 has a sine value of √3/2? And that's going to be this angle up here, which is π/3. Going back to this one, 3/2 is not a unit circle value, right? So I'm not going to find that on my trig chart. I'm going to look down the sine value, and I'm not going to see 3/2. Obviously, I see √3/2, but I don't see 3/2. So if that's the case, if this is not a unit circle value, you first have to ask yourself, is this thing between -1 and 1? Because I'm only allowed to plug things in between -1 and 1. And so is 3/2 between -1 and 1? Well, we could also try to do inverse sine here in the calculator, right? So I will just go to my calculator. I would say go to your calculator if it's not a unit circle value. But what happens when we plug in something that's outside of that range from -1 to 1, which 3/2 is 1.5, right? So that's bigger than 1. It's not in that range. It's undefined, right? So this doesn't have an answer. It's undefined because 3/2 is not in this domain from -1 to 1. Okay, but again, just because it's not a unit circle value does not mean it won't have an answer. Like if I plug in some fraction that's not a unit circle thing, so let's just say I did inverse sine of 1/3, right? 1/3 is not a unit circle value, but it is between -1 and 1, so I do get an answer here. So check in the calculator, but if that thing is not between -1 and 1, you can't do it. All right. So the key thing here is just knowing where to look on your unit circle or in your trig chart, and that is in quadrant 4 and in quadrant 1. But in quadrant 4, we're just calling those negative the angles that we have in quadrant 1.